Yeah, so I'm just, as far as identities go, I'm a runner, avid outdoorsman, and I love math and robots. I've been working on robots since I was very little. I'm very energetic whenever I start talking about it. I really enjoy it, and it's always been a passion of mine. And so if left alone, I'll just sit around, code, and start building something, because it's a wonderful thing to be able to take an idea that you have in your head and turn it into something new, something beautiful that can then just run, and then you can just take a step back and look, hey, I built this.
My name is Alex Polonsky, and I am the founder of the Detroit Autonomous Vehicle Group, and by day I am an electronics engineer at Broza. Born in St. Petersburg, Russia, into a family of engineers. We moved to San Francisco, and always been fascinated by cars, so continued kind of working with cars, and software was always there. And then in 2011 I followed my passion and moved to Detroit. So just gave up my life in San Francisco, California, didn't have a job, and just moved here and found a job in 3 weeks, and now here we are. And in 2017 we founded the Detroit Autonomous Vehicle Group.
So I was little, I grew up in San Diego, got my undergraduate degree in computer engineering from Purdue University, then moved out to Michigan where I met Alex, and I found a community that was filled with people like myself that likes building things. You know, we better each other, and that's a wonderful thing.
So I'm an engineering student just wrapping up, and I'm doing a dual degree in mechanical and computing technology. I transferred from Windsor, and I was actually involved with the Detroit Autonomous Vehicle Group a while back, and at the time I was working on an RC car-based self-driving project, and I found out about this group on Meetup. I started meeting with all these people and working a little bit more on this project, getting some help from others and connecting, and also shared some of my ideas. I actually transferred to U Ottawa and started a community there in Ottawa, and yeah, here I'm, you know, back to visit and represent and kind of show off my donkey car project, and it's cool to be back with the community here.
So I became involved with DAVG as one of the founders of the A3VG, which is the Ann Arbor Autonomous Vehicle Group. So we're kind of a sister to the DAVG group. And then I, like many others, came to it looking for an on-ramp to learn autonomous vehicle or autonomous mobility technologies. And that's pretty much what the DAVG offered. And then we ended up partnering together on a number of exercises and projects and events like this one here.
The group's purpose is to serve the community, really. We want to have a safe place for people to come, experiment, play, break things, and learn, all while having fun and building relationships.
I think certainly one of the most enjoyable aspects is the camaraderie, you know, and collaboration. You can discover new things, improve your skills, leverage other people's skills. It's a very open community on the one side. I think in addition to that, you have people that bring different dimensions to the equation. In other words, beyond just our core focus on the racing, you've got people that are actually in the automotive industry working on machine learning algorithms, whatever it is. So that sponging effect of bringing in industry into that smaller group is definitely one of the interesting benefits.
Okay, so the robot originally started years ago. It was my buddy Luke and myself. We built it was basically a plank with 2 bicycle wheels on it. We had no idea what we were doing. We were software guys, not really familiar with mechanical engineering. The fact that we got the wheels to spin was a miracle. It graduated to being controlled by a smartwatch, and then later we had our senior design project at Purdue, which was a similar version of the robot. It was a 3-wheeled robot that could drive around campus. But I wanted to take it further, and so on my own time, I basically we scrapped the senior design project and took the parts off it, and I took my parts and then we rebuilt it in my apartment, portions of it in the workshop, reconfigured it and basically brand new design, and got it up and running to have more capability, more capacity, more sensing. I use it as a test bed for algorithms that I find in books and papers. Just for fun, I implement a portion of the algorithm, or I add a new sensor, better, or I add some new feature to it, and then I get the excitement of immediately being able to go in, program, and then see my result. So that's a robot rolling down the trail, and then you can see here the map that it's building. White is occupied, black is free space. Obviously there's some sensor error on the outside, but the white is the bushes on the side, and basically anything that the robot itself can't actually traverse. And so it's moving, each pixel in here is a 10 centimeter grid, and the robot's cruising down the trail and making a map as it goes. It's using the GPS, which is up here, to figure out where it is in the world, combined with the inertial measurement unit and the number of rotations of the wheels, and then it creates the map.
Yeah, so like initially I bought a very inexpensive RC car that didn't have like a servo for the steering or anything. It was just left-right, and I just wanted to, you know, first figure out how to control it, and I didn't know how to solder or anything at the time, and I went from scratch kind of and opened up the, you know, transmitter and trying to figure things out, how to connect to an Arduino initially, and then I progressed to buying like an RC car, like a more of a hobby grade model, and then at the time a popular and even now community is called Donkey Car, and it's like an open source project basically to be able to hack an RC car and download like their software stack and you know, put some parts together, and everything's open source and supported in this community. Here's my Donkey Car project. This is one using a Raspberry Pi. There's also support in the community to use a Jetson Nano, and I have a different base here which is future plans kind of thing, but it's using an RC car base. This is a Traxxas. It's kind of a nicer one, and this part is kind of the standard one you print, 3D print. I have my car, basically what the operating system's going on here, and I'm in the My Car folder, and I'm gonna run a command to actually start the car. So now it's just going through a bunch of checks, and now it's actually broadcasting over Wi-Fi. And so I have the IP address, and on my phone here, I'm gonna refresh the page. I was already there. But basically I can see, you know, what the camera sees, so I could drive around, and I can actually control it with this kind of joystick here. So I'll turn on the ESC, should work. Battery's a little low, but I can steer left and right. And so I'm gonna actually try doing a couple laps here on the track, and so doing this, I can collect a bunch of data, training it. So I'm collecting what the steering is, and it's taking a bunch of pictures. So collecting the steering and the throttle. So we're using that data afterwards to train a neural network, and then having a trained neural network, we can load it back onto the Raspberry Pi, and then it will predict what the steering and throttle should be. So your battery's getting a little low, but it's, yeah, and the fun thing is that the driving matters during the training. So if you drive bad, it's gonna learn to drive bad. So it's key to be consistent here, because it's looking out for, you know, for that when it's training the model.
So this is actually the PIX Moving AV EV development chassis, so autonomous vehicle and electric vehicle. It's a smaller form factor to a full-size vehicle, yet it can accommodate a full automotive scale sensor stack. So what you're doing with this, you can test your algorithms, you can test your sensors, and you can develop your own solutions, perhaps mobile retail, security solution, fire suppression, whatever it is, all sorts of options. So we're trying to kind of act as a catalyst for a development of the mobility stack, assuming the autonomy is almost a given. You have 4 motors, 4-wheel drive. We have 4 72-volt, 3,000-watt hub motors on here with hydraulic steering, so it can steer each axle independently, and the motors can be driven independently. And you also have 4 independent motor controllers, a CAN bus on board, and here we actually have, to show the flexibility of the platform, this is the second battery and battery tech that we've used here, but in the spirit of doing development and repurposing and reutilizing. We actually have 72 volts of power being delivered by repurposed Nissan Leaf batteries. But everything is laid out such that a person could easily change components, swap out batteries, swap out power supplies, and really leverage it for their own specific needs. And it also lends itself to what's known as the software-defined vehicle architecture.
We had an opportunity to go to Kettering University in Flint and interact with kids ages of 3 to probably 15. And what I was the most surprised by is how engaged and involved the 3-year-olds and 4-year-olds were. And they even on their own learned how to make the car work. And that was really satisfying to see that maybe later on, 10, 20 years down the road, maybe that was the spark that gave that kid and he becomes an engineer later. To see people sitting at the table together, working with one another and learning from one another, I couldn't think of a better. I think that's fantastic.